Good morning again. We can start the second section. So first we should know what is the basic format of images. So two basic formats available, grayscale image and RGB image. So in the grayscale image, all colors will be in the shades of gray. So it will start from darkest dark to whitest white. So the totally 0 to 255 ranges are there. And in RGB image, it is a combination of red, green and blue channels. For each channels individually, we will have 0 to 255 colors. And when compared to the RGB image, grayscale images small in size. So in most of the applications while running the codes, we will use RGB grayscale image only. If your input is available in RGB image also, before processing, we need to convert to grayscale image, then only we need to process. So grayscale images are widely used in medical imaging, machine vision and image processing. RGB images are widely used in natural photographs, digital graphics and web images. So medical images analysis in using computer vision. While we speaking about this, we need to speak about machine learning and deep learning. Because while handling large number of data sets, we need to use definitely machine learning and deep learning because manual analysis is time consuming and error may occur. So machine learning and deep learning are the methods we can use. So in the diagram, the first one is machine learning, the topmost, and the second one is deep learning. What is the key difference between the machine learning and deep learning is, from the input images, if we extract the features of the images, for example, shape, color, or whatever may be the application, based on that we need to extract some features, and if we give us a input to the algorithm, then it is machine learning. Directly if we give the input images and training the system, from that automatically if it is taking the features means it is deep learning. So when compared to machine learning, deep learning is widely recommended because it can automatically take the features from the inputs itself. So to work with medical images using machine learning and deep learning, we can use Google Colab. Many tools are available. This is one user-friendly one. So we have some demo by using this Google Colab. So we can open this Google Colab by using this link. So if we search Google Colab and it will open like this, then we can take new notebook. So here you can paste your code and if you run, you can see your outputs. So first we need to install the recommended libraries. So based on the application, whatever libraries required, we need to install. So here OpenCV, Python and PyDcom, Matplot libraries are installing. So now we installed the record libraries. Now what is the first step is we need to give our input to read and display an image. So we can, if we plus code, it will give another section. Here we can paste our next code. So if we use like this uploaded equal to file dots upload, we can give our image directly without specifying the folder. We can select our image from by clicking this choose file. So from this you can select your own input. So now I give this name 10.jpg is my input. It is saved in the same name itself. If I want to display this, I can use this same name. So now in the next section, we can use the code to display this image. So already it is stored in the same name 10.jpg. So I am using the same file name here. And here I am going to display a grayscale image. So I am using the color map as gray. If it is a RGB image, we need to use RGB. I will show another example. So here, this is the uploaded grayscale image. In the previous code, I stored. Now it is displayed. Now how to upload a image in DICOM format, because even though this is a medical image, it is stored in JPEG format. Okay, directly if you want to upload a image which is in DICOM, so here to display this, we need this PEC-Artificial library. So it is installed. Then we need to give the input. So by clicking this choose file, I need to give the input in DICOM format. So it should be stored in .dcm format. Then only it will take. So now the DICOM image is saved in the same name and I displayed here using the grayscale color map. So here it is displayed the DICOM image. So now some pre-processing examples. So resizing. So this is the original image. Now the size of the image is changed. is somewhat reduced. So here the image is resized to 224, 224. So any dimension if you give it will change. So it is 224 up to in x-axis and in y-axis also 224 it is displayed. If you give another number, it will take up to that number. Or 0 to 255, some numbers you can give. So now it is again resized. In x-axis it is up to 234. So here some more spaces are when compared to this axis. Now normalizing. So here for normalizing, we are dividing the image pixels by 255. So this is the normalized output. Now histogram equalization, it is one of the pre-processing technique. So here it is increasing the intensity of this image. So this is the original image. Now it is improved so much we can see. So if you give this code equalize hist, it will take histogram equalization. So another one method of histogram equalization is adaptive histogram equalization. So here we are giving one clip limit. So that is equalization is we are fixing the intensity values. We are increasing the range of frequency value, intensity values. So here after this clip limit, the intensity value will not be allowed. So here it is fixed as 2. So now this is denoising. So to remove the noise, we are using this denoising method. So here the code is this line denoised equal to fast N1 means denoising. Now to display a color image. So now one RGB image is given and displayed. So here what is the difference in displaying this RGB image and this grayscale images? Here the color map we should use gray for grayscale image and color color BGR to RGB. This is for color image. So both in color format and in grayscale format it is displayed. So to convert this color image to grayscale image, convert color to gray. This command we need to use to convert the color image to gray image. So this is for data augmentation. So what is the use of data augmentation is we can increase the number of input images by flipping, rotation or by adjusting any parameter we can produce more number of data set because while analyzing with machine learning and deep learning if input images number is high means the accuracy will be improved because it will trained with more number of images means the accuracy will get improved. So in some applications if you have very less number of inputs in that case by using the existing data set we need to generate more number of data sets. So for that we can use this image augmentation. Here for example by using this one image we are getting 5 images by using this image augmentation. So by flipping, scaling and rotations, we can getting this augmentation output. So now to get the region of interest or a cropped image. So from a original image, if you want to get the particular portion, we can using this cropping or region of interest selection. So this is the original image and here this is the cropped region. So in this example, we are cropping the center portion alone. So here the height and width is given. If you want another regions, we need to adjust this height and width, then we can get another region of interest. Now another one important thing in image analysis is edge detection. So to display the edges properly, we are using this edge detection. In some applications, it will be very useful. So here the edges are displayed